Hello, everyone. Welcome back to MedZone African Motives. We are still on our Mechanotechnics N6, and that is working with the reduction gearboxes, which is part of our module 5. So basically, we need to have the basics from our N4. So just go through working with the gears in N4. uh, yeah, all the basics, simple, and those compound gear trains. So that's basically what you need, because as you are to work with the reduction, when we say reduction, from the word on its own reduction, there is a decrease of something that is to happen. So, what is it that is to reduce? Reduction gearboxes are used in numerous industrial applications where the major part is to reduce speed. To reduce what? Speed. But as the speed reduces, the torque increases and increase torque. That is the case now. So we are to reduce speed and increase what? And increase the torque. So I'm not going to waste your time. We're going to quickly rush to what we need on our calculations. So this is gearboxes, mechanical devices that change the primary input speed received from a driving source into a different output speed by using what? A series of gears. So that application will end up having our speed being what? Affected. So they are used in many applications, such as industrial equipment, the conveyors, and any rotating motion power transmission that requires change in what? Change in speed and torque, as long it is about speed and torque. It can be used. We can use what? Our reduction gearboxes. The gears in a gearbox can be any one of several types. We can have spar gears, helical, bevel, worm gears, rake and pinion, as we had from our previous levels, from our N4. Remember, but in our case of N6, of these reduction gearboxes, we shall concentrate or focus on spar gears and what? And warm gears. So those are the ones that we are going to actually be focusing on. So I do not want to waste your time, guys. What we are going to simply consider will be part of the calculations. And the first thing, as long you are to consider gears, remember the gear ratio as we had before. All right, so that is the first thing. So for those who need much of this theory, I think if you check the TVET series textbook, yeah, they have a lot of theory, but that is for N4, so it won't be of any use because, but for those maybe who just want a recap of N4, then use the textbook, that one for TVET series. Yeah, it has a lot of theory when it comes to reduction gearboxes. All right, just gonna uh, try and have, but that is it's gonna try send it or have it in the drive so that you can download the book and just go through. All right, and also guys, you must follow the playlist. Everything is in the playlist when you're studying for any other topic. Use playlists. All right, don't just search, because remember, in the playlist you can see everything that is in within, and some videos are meant for members. So they'll be there also in that playlist. So you study using the playlist. Even for this topic, you studied from the introduction up to the end. Following the playlist, you see that it will be easier for you to catch up. Do not just search. You want this, you search. Use the playlist. All right. If you go through the channel, you can see the part of the playlists. All right. There can be many playlists. Scroll down, you will see the one that you want. As long I have done that, you will see it. All right. And if there is any playlist which is not yet complete, that is the purpose of the comment section. We must communicate this playlist. Something is missing. We do not have all the videos. This section was left out because sometimes you might think that I've done everything, not knowing that you left something because of too much things that you'll be doing for that particular moment. So let us also communicate using what? The comment section. It is there for us to understand each other. All right. So, like I said, without wasting your time, the first thing when you're to deal with the gears, it is the gear ratio, and that is referred, can be referred from the torque. It can be referred from the speed. All right. So from the torque, we are going to say this is the torque of the output. Let me just write T out. So when I say out, I'm talking about the driven, which is the two at the end. That is your driven. When I'm talking about the in, when I'm talking about the in, that is the input, it's at one, and those are the drivers. All right, those will be our drivers. So that is two for the driven. So I'm just going to use two. All right, two over what? Over one. So meaning to say, we are talking about the torque on the driven, T driven over T driver. All right, we are talking about output over input, T out over Tn, one and the same. So this is what I'm trying to say. All right, if you understand this, it's one and the same as this one, again. So it is in your hands. Which one are you going to have? So there we referred from what? From the torque, like this. It can be referred to the speed in revs per minute, input over output. For speed, it is input over output. There is only for torque, which takes output over input or driven over drive. The speed, input over output, even for the angular velocity, it's 1 over 2. Input over output, even for the angular acceleration, it's 1 over 2. All right. So this can help us to calculate the anything, like let's say from that we have got the gear ratio. We can equate these two. All right. We can equate these two. We can equate these guys depending with what you want. And mostly you'll see that as we deal with those angular acceleration and velocity here, these can be related. Somehow we can relate this to this one, depending with what you're given. We can relate this one to this one depending with what you are given for that question. So it can be used to even answer anyone, provided, let's say we have got all this and we have got omega 2. We want to calculate omega 1. We can simply use this equation and find what? And find omega 1, because that will be the only unknown. Let's say we are given this and this and this. We want to calculate this alpha 1, which is our angular acceleration in rad per square second. We can equate these two. So you see where the gear ratio can be used. So the gear ratio, very, very important. As your recap from N4, you must add this part when there is an acceleration that is occurring. All right. So like I said, we are going to look into the gear trains. which in our case, for the sake of revision, I'm going to focus on the simple gear train so that we have examples on that. Then we look into the compound gear trains after that, all right? Because we end up having confusion on what we are doing. So when we are to refer or when we are to consider the gear trains, all right, when we are to consider the gear trains, it's simply a system of gears that transmit motion from one shaft to another. All right, let me write it down. A system, simply a system of what? Of gears. Simply a system of gears that transmits. So it transmits motion from, take note there, one shaft to another. All right. So that's the basically the thing about our gear trains. All right. So these gear trains are to be given as a simple or a compound. So in our class, like I said, we are going to focus on a simple gear train, which is what? Simple gear trains. All right. Remember from your N4, a simple gear train in our view, we are going to consider that is there is only one gear on each shaft. There'll be one gear on what? On each shaft. So a basic view of what I'll be having here is, all right, something like this. So we're gonna have gear A and what? And gear B. So this is gear A and our gear B. So gear A will be connected to the input shaft. All right. So it's going to be connected to the input shaft. So this is our input. So it will be connected to the input shaft, which we call 1. So the input is 1, and B to the output. So B is connected to the what? To the output, which is 2. To the output, which is 2. So when we consider this, we must be very, very careful, guys, because we are going to refer on our calculations about the inertia. The moment of inertia, which is taken from the input, it's sum of all components on the shaft 1, on the everything that will be having there, that will be part of that shaft. 2, what is on this shaft, everything, because we are going to have later on when this shaft can also carry a drum or something. So it means if a shaft is going to be connected to a drum but it is from a gear system, it means whatever part of the gear system that we have and the drum that you are going to be having must be combined together to give us the moment of inertia. So in our case, we won't see the effect here because there is nothing connected to the output shaft. There is nothing connected to the input shaft. So as of the moment of inertia, we won't see the effect on a simple gear train like this one that we are having. All right, but for the simple gear trains that we have there, we consider gear A to be the driver on the input shaft. So gear A is our driver, and gear B is what will be the driven. So that's the driver or the pinion. Then B is the driven or the what or the wheel. So that is what you're going to have. And from there, we can have calculations. All right. We can have calculations. So like I said, I1, the moment of inertia, all right, on the input, it represents the sum of the initial sum of all components. So this is the sum. That is the sum of what? Of all components on shaft 1. Of all components. Which are found on what? On shaft 1, which is what we have on the what? On the input. It's inertia. Remember, moment of inertia measured in what? In a kilogram what? Square meters. Moment of inertia, guys. We dealt with the moment of inertia before. Mass times radius squared. Some they use radius of gyration. If it is just a radius from what you're given, use that mass times distance squared. So it's going to be kilogram meters squared. All right. Then the moment of inertia on the output is going to be referred to as what? As I2. So this one, it is the sum also. So it is the initial sum of all components that we have on what? On the output of all components on shaft what? On shaft 2, which is the output. So take note of all components. All components. So we have to consider that everything is there. And for any other adjustment, we'll see. But that one is going to be when we are using compound. All right. So there we can calculate the equivalent moment of inertia can be calculated. The equivalent moment of inertia. So the equivalent moment of inertia thus now can be referred to the input or it can be referred to the output. The what? Equivalent moment of inertia. It can be referred to the input. It can be referred to the output. That's what our equivalent moment of inertia. So also affected by efficiency if at 100% efficiency or we are not given efficiency. When you are not given efficiency, it means you are at 100% efficiency. Otherwise, they are going to give you efficiency. So at 100% efficiency, or when we are not given efficiency, when you're not given efficiency, they're assuming that it is at what? At 100%. So we can have the equivalent moment of inertia referred to the input, When referred to the input, we're going to indicate 1 for that. Input. Referred to the input. So that's equal to I1 for the input plus I2 into. So here take note. You use the speed, but the speed must be when you say referred to the input. So the input will be in the denominator. The speed referred to the input is the one in the denominator. So meaning to say the output is going to be on top. So it's N2 over N1 squared. So speed, the one in the denominator is the one referred to the input. So it's the one that is in the denominator. So this is the formula that you are going to use for the equivalent moment of inertia referred to the input at 100% efficiency, or when the efficiency is not stated on that question. So that is it here. Referred to the what? To the input. Okay. Then we're going to need another one that is referred to the what? To the output. So that's IE2 output. So as we see, this is 1. This we started with 1. So when it is output, we're going to start with the output moment of inertia I2. So it's I2 plus I1. Then the speed, as I said, referred to the output. So the output will be the one in the denominator. So definitely it's going to be what? N1 over N2 squared. So this is what you're going to have referred. All right. So this is referred to the what? To the output. Okay. So this is what you're going to need on a simple gear train at 100% efficiency. That is what you need. And from there, we can have calculations, guys, which are used or which can be used in terms of what? In terms of our torque, we can have that. Output torque can be calculated from there. All right. From these equivalents, we can calculate the torque. All right. Number one, the input torque can be determined. The input torque. So you can write T1 or T in. It's in your hands. You can write T in or T1. So the input torque is going to be equal to, since we are dealing with the, all right, remember torque is equal to what? Moment of inertia times angular acceleration. So when it is input, you use equivalent. The moment of inertia must be the equivalent one. So other textbook, they call this one IT. IT, equivalent, they call it IT. All right. So as long you know that IT that you're talking about, is it for input or it's for output? So here writing to say IE1, IE to specify that this is for input, this is for output. All right. Then definitely you're going to multiply to the what? Angular acceleration that is on the input. Angular acceleration that you're given in the what? In the input. So that is going to give us the torque. Just like that. So IE1 is what we have already here referred to the input. So we already have this one referred to the input and the units kilogram meter squared. All right. The angular acceleration that you have with already, you'll be given that. All right. Remember in rad per what? Rad per square second. But also remember, guys, as you dealt before, whenever you're dealing with angular velocity, acceleration, this you must also refer back to angular motion calculations. All right. We dealt with that one even from your science, engineering science. So do not forget about those as you had them before. So that's basically what you need. And the torque is, we know that is measured in what? In Newton meter for the sake of units. All right. So this was the input. What about the output? Output torque can also be calculated if we have the output, which is 2, referred to the output. So it follows that T out is going to be the moment of inertia that we have referred to the what? Output times the angular acceleration for that output. So in most cases, you will calculate this. Definitely, you've calculated this. You've calculated this. They will give you one of these, whether you're given alpha 1, angular acceleration 1, or you're given this one for the output. They won't give us both for these two. It is either you are given one. Why? Because they want you to calculate the other one by yourself. So given omega, angular acceleration 1, which is in rad per second, you're given this in rad per second. Given. You do not have alpha 2. You do not have this one. What can you do? You have only this, but you need it here. You refer back. Remember, I talked about the gear ratio now before. That formula is used, guys, to calculate whatever that you have. So if I have this angular acceleration, I must check throughout the formula of my gear ratio. Which one is it that I'm given? Am I given these? Or am I given N1 and N2? In most cases, you'll be given N1 and N2 from your information. So meaning say you can equate that, this one to this one, from your gear ratio. So it depends with what you're given. So let's say we have N1 and N2. Mostly they will give you this. So it means you are now using the gear ratio now to say N1 over N2 is equal to alpha 1 over alpha 2. You play around now to say, how can I calculate my alpha 1? So that's where you see your textbook. They just write alpha 1 is equal to, they've already removed this by multiplying by it here, multiply by it. Then you just see them writing N1 over N2 times alpha 2. You wonder, where is it taken from? From the gear ratio. Also, we can make that alpha 2 the subject. So this is used now if I am to calculate alpha 1. Given alpha, I have this, I can simply calculate my alpha 1. So if I want alpha to this one, let's say I'm given this and I want this one, I simply have to do the same. So you have to cross multiply. So it's going to be, all right, or this one you can just, if you do not want to have confusion, just interchange them. N2 over N1, interchange here. You also interchange here. So it will be alpha 2 over alpha 1. So it will be easier for you to find alpha 2 because you just have to multiply by what? You just have to multiply by alpha 1. So this can cancel. So therefore, this is for what? Alpha 1. And our alpha 2 can be given as what? Here, it's going to be N2 over N1. So it's N2 over N1 times what? Alpha 1. That's it. You have alpha 2 as the subject of the formula from the gear ratio. From the gear ratio, that is where it was taken from. From here. So you'll be wondering, you're just answering questions, textbook, there's this formula. Where is it taken from? They don't even explain. You must know where it was taken from. You must know that. All right. So this is it, guys. I don't know. For any part that you do not understand, I think we'll duel with that one with questions. That'll be our next class one for this one. I never thought it's gonna be this long. But let me just finish up so that we can have questions in our next class. All right. So that is it. If you consider from what I just had here, it was based on 100% efficiency of the system, or when we are not given the efficiency, we assume it what? It is 100%. With any other efficiency given which is not at 100%, any other efficiency, guys, those calculations will change. All right, so here I wrote, did I write 1 or 2? Let me just write A here. Let me just write A at 100%. Then B, I'm gonna calculate those equivalent moment of inertia. You understand me very soon. You understand me very soon. This time with efficiency. Let me just say with efficiency, guys. You know what I'm trying to say here. With efficiency. All right. 100%, you cannot say that one, guys. 100% is just one, all right? 100 over 100, it's one, so there's no effect. So when I'm saying with efficiency, I'm talking about any other efficiency from whatever that you have, which is not at 100%. All right. So this is what I'm trying to say. Number one, as we refer to the primary, which is the input, one input. This is what you had. So when there is efficiency for the input, you divide the second one. The first one remains this part here. It is like a reference point to say from the input, you start with that output, you start with that one. So no effect, no matter whatever that you're going to have later on, there is no effect that will happen on this one. So you ignore that, you move on to the second part. So you start from the second part going on, because there can be other formulas when you're dealing with compound gear system. So you always start from the second one. That's where the effect happens on the efficiency. So here there's no effect. I1 is not affected. It's just going to remain as it is. So it means IE1 is equal to I1 plus I2. Now this one is now affected. For the input, you divide by the efficiency. So it will be I2 over that efficiency that you're given. So this is what you're going to have. The rest remains as it is, N2 over N1 squared. For that, you divide by efficiency. Divide by what? Efficiency. I2 over efficiency. The first part not affected at all. And this must be a decimal. Remember, whenever you are to substitute your efficiency, you substitute it as a what? As a decimal. Divide by what? Divide by 100. Divide by 100. So this is it, referred to the primer. Equivalent moment of inertia, but referred to the what? Input. Referred to input. When referred to the output, just like what we had, we're going to have this one not affected. The effect will be on I1. But for this one, you multiply. For the output, you multiply by the efficiency. That is the only difference. So you take this as it was, only that part of what? Of I1. So it will be I2 here plus The I1 that we had on the output is multiplied by the efficiency. Please take note. You multiply by the efficiency. The rest remains as it was N1 over N2 squared. N1 over N2 squared, like this. So that's referred to output. This is what we have referred to output. So please take note on that one. You multiply on the output. Input, you divide by what? Efficiency. Just, okay, but I think it's something that you can recall. Input, divide, output, multiply. All right. So this can be used later on in an expansion. We're going to expand it later on, but that is what you're going to have. All right. So from here, just like what we had before, remember, after this, we managed to calculate the torque and what these relationships that we were having before. So in our case, it is still the same thing that you can actually have for our calculations. It is the same thing that you're going to have for the torque, this and that. The only effect here is going to be on the gear ratio, because we have an efficiency which is not at 100% at any other value. So you find out that your gear ratio this time will be equal to T out, which is T2 over T1 times that efficiency. So meaning to say, if I am to calculate the torque now from the gear ratio, I have to include efficiency this time. I have to include what? Efficiency. So I can calculate T2, T1 from this. T2 will be equal to T1 times this efficiency times what? The gear ratio. You just have to cross multiply. You see, I can even find T1, make T1 the subject. So it means it's what? T2 over what? Efficiency times what? Times gear ratio. That's it. I can play around with the formula. It's in your hands. But those calculations that we had before, say T, when we have the torque there on the input, which is simply our T1, when we have the equivalent moment of inertia times the angular acceleration, still works. When we have this one, as long as we are using equivalent to its angular acceleration, still that is gonna work. And the relationship between angular acceleration and speed, this one here, still one and the same thing, only that now there is a direct effect of the efficiency that we have to use, which was different from when it was at 100%, because 100%, the moment you divide by 100, you get what? A 1. So wherever there is efficiency, simply a 1. Here, simply a 1. So you see that there's no effect. You won't see that effect. So this formula is actually the general formula. You can use it. If you want, guys, if you do not confusion, say I have to know this, then I have to know this one. Use this one. If they say 100% efficiency, just put a 1 there. You're done. So that you don't have confusion. But if you can master the two to say, okay, but there's no difference. It's only that here divide by what? Divide by efficiency. Here multiply by what? By efficiency only. Input divide, output multiply. Only that. So we are going to look into questions based on what I have explained in the next class. I think we're going to look into those questions. And after that, we are going to have another class again, having formulas like this, but we will be based on compound gear trains. which is the major part of our syllabus, compound gear trains. So you see that will be almost done after that. So do revise, do questions, join membership so that you do not miss any of the other revisions, examples, questions that we are going to be having from now onwards.